stuff like in a Word document or whatever, and have all those links that we can just copy and paste and be ready. Like if you're gonna, you know what I'm saying?
Yeah,
Like back up your
exactly.
shit. So when they, yeah, go ahead, Chemo.
Absolutely, absolutely. So of course, the globe earthers are not fond of these solid arguments because it makes life very difficult for the globe earther to argue against. And that's the goal, isn't it? The goal is to show the world that the globe earthers do not know what they're talking about, do not understand science, do not understand the world around them, and are struggling to come to terms with the lie of the globe. So, of course, I mean, I recommend any up and new coming flat earther to use these arguments. Use the arguments of the black swan. Black swan is very effective. Very effective. If you try to get the
Number one.
glober to explain where the geometric edge is, you'll find it very, very difficult to pinpoint and locate that. No edge, no geometric horizon, it's welcome to flat Earth, because then that means obviously we can't measurement. So the scientific method we tried again with illegal and bio to go through, and even Veach was involved. Many different methods we were told, but we always came back to the method that has the independent variable. So it doesn't matter what we do. Everyone agrees, I think, at least when they try to conduct science, that their only success is when they follow this method. Now, again, you can try any method you like. Let's take a look at your method. Let's see the results, and let's see if we can do science with that. So, it is very difficult for globe earther to demonstrate without this method. So, that's pretty much it, really. I mean, we've got, glad to see Andrew, glad to see Illegal. This is what you wanted to see. Jen, this is what you wanted to see, Ball Earthers. You wanted to see the new faces, the new voices, who, where, what, who's. And we brought
it.
Are
you still talking?
Sorry? Sorry. Am I talking?
Somebody said something.
Who? I don't know who was speaking. Who was that? That Tom. So yeah, I mean, like I say.
No, but
go ahead.
Same thing with science. We need to have these citations and references and everything to back up what we're saying, because I mean, the same thing they're saying that I hear is the same thing I grew up and I would be like, yeah, that's right and correct. But then and they always say they want to use the ad hom of, oh, that's QE's this and that's QE's that, and it's like, no, it's we have the references from these colleges and these reputable
yeah, all
sources.
from the universities. Yeah, he didn't just make them up himself. All he did was point out, he's like, hey guys, have you seen this? There's an actual method that you can follow. And we're like, oh, okay, what's that method? And
we need to have those links too, so that when they pull that QE shit on us, we can just give them the links and say, no, these are the links.
QE's done wonders. I can't see what the problem here is with QE. I mean, again, QE has put the questions in order for future flat earthers, fence sitters. They want to challenge the globe earthers, and to be successful is to follow this line of question. Now, of course, you don't have to. You can use whatever method you like, but this is cited from universities, like Illegal just said. And
of course, the big problem with QE is that every one of his citations is misrepresentation of what's said. If you read paragraph beyond or before.
Yeah, well, we've never seen that been highlighted with QE.
Looking behind his back. Oh my God! It's been highlighted.
We'll cross that bridge another day when we have the links and we can go through it, and then you can make your point and we can go through that. But now is not the time.
Even still, there's not even an argument here. If you have another method, let's try and use that method and see if we have results. And what we'll find, it's those methods are based on your best guess, not.
Would it be a fair position for me to say, Timo, that you believe the Earth is a globe?
No chance.
I could show you citations where you've said it is.
Oh yeah, in terms of begging the question, yeah, you've got to beg the question.
Well, no, I mean, I've heard you say it. So I
I
mean,
have said it. Yes, I've said it many times.
Would it be fair of me to say that your overarching position is that the Earth is a globe?
Well, I'd have to have evidence.
Well, no, you know that you've done it. You said you've done begging the question, but I will say the words came out of your mouth
Yes,
that the Earth
many
is a
times.
globe. Therefore, would it be fair to say that Chemo believes the Earth is a sphere of 3959 radius?
Yeah, that's what we were told. Yeah,
So would it be fair that that's what you believe?
say that. Yeah.
So that'd be fair that you believe that. Okay, you don't even know your own position.
No, that's fine. It doesn't matter if I'm a globe or not. The point is can I make measurements? Can I use science to prove what my belief is? Doesn't matter what I believe, right?
People misrepresenting what you say.
That's why I would say I could say, all right, I'm a glober. That's what's happened many times. So there's someone said, okay, I'm a glober. Now let's go through the measurements. What is the radius? Then they'll go through the radius, like you just said, 3959. Then we'll ask you where is the geometric edge, and then you'll say, well, we can't find it because it's apparent, not physical. And then we go back to the flat Earth. Not that difficult. Be a glober and then a flat earther just like that, simply because you have no geometry.
Well, see, the problem is every time we come up with a geometry which is completely coherent and scientific and repeatable, you just say nuh-uh, because the shape of the Earth is most accurately measured by measuring angles to stars. And you say, oh, that's illegal. Well, you don't get to say what pieces we do or don't get to use. You'll have to find a technical flaw with it, with either your own data or evaluating the data of all of the centuries put together, like your Royal Engineers, Ordnance Survey UK, Survey of Mount Everest, Academy of Sciences, Meridian surveys. You know, you're going to have to get very specific with the cumulative data of the centuries, and not just, oh, I have a black swan photo.
Fuzzy.
Yeah, you really got to come up with some actual evidence, Chemo. I'm sorry, just denying what's out there is not a solid method of coming to truth.
I mean, I'm not saying that I enjoy that you don't get it, but what it does is give us an opportunity to explain the argument once again. You know, when you say, when someone like Larry here says, oh, well, you've just got a black swan image and that doesn't prove anything, that shows to me that Larry doesn't understand the argument. So obviously we get to go through the argument once again, because if he did understand the argument, he wouldn't say, well, you've only got a black swan image, because the black swan is every horizon, Larry. Everywhere in the world. Yeah. There's not one horizon in the world. What?
Okay, what you don't seem to understand is when you get close to the water and looking out, optics of the horizon affected by atmosphere makes such a high noise and ambiguous scenario that it doesn't return any science about the shape of the Earth, because we have conflicting photos. So that kind of rules out photos of the horizon. So when we see stars, then, and with proper kit and accurate measurements, that ambiguity disappears. Then Larry, there is no ambiguity, and it is repeatable.
Larry, again, you do not understand the argument. Okay, you said, "Oh, well, you're only 1 foot off the ground." The height doesn't matter. You could be 10,000 feet off the ground, 30,000 feet, 100,000 feet off the ground. You, Larry,
they told me basically
Larry,
due to refraction they could see forever.
You will never see the geometric horizon, Larry, at any height.
Okay,
1 foot.
And you know what? Mm-hmm. I'll agree with you on that. Absolutely. That's why we don't
Welcome
use
to flat
that. That's why an ocean horizon is never used as reference. You notice every instrument, from a carpenter's level to the big astronomical telescopes, survey theodolites, everything runs off the gravity vector, not observing a horizon. The only the exception to that is when you're using a sextant in the ocean for vertical angles to stars for navigation. That's like the only application I know that anybody references that horizon for anything. We all come off
Larry?
of the gravity vector, a carpenter's level, all the way up to the astronomical telescopes, surveys, instruments. They all use the gravity vector.
Larry?
When we measure from vertical, we are not measuring from the ocean horizon because we know it's ambiguous.
Larry, quick question. Are you sure that the sextant uses the horizon? I didn't think it used the horizon.
Yes, a sextant does, because from the observer, you measure the angle with a couple of mirrors and the angle arc. You impose the image of the sun on the horizon, and you measure that angle of displacement. And
You didn't get the
then
memo,
you go to
Moya.
your correction. And you go to your correction tables, and it says, "Oh, by the way, yeah, there's a minute here of refraction. Oh, yeah, and you're 12 feet above the water because you're in the wheelhouse. Oh, yeah, and you correct for that." But that is the only time, the only instrument that I know of that uses the ocean horizon as a reference, and it uses it with corrections because the Earth is a sphere and there is optical distortion when near the horizon. But when you're navigating with a sextant, a half a mile is insignificant typically, because when you're trying to find Hawaii, if you get within 10 miles of Hawaii, you put your sextant away and just go for it. And yeah, everything comes off the gravity vector. When you see a carpenter's level, what is it using? Are you sighting a carpenter's level against an ocean horizon? No. When you use a survey theodolite and you level it up with its meticulous little level vials, are you observing the ocean horizon? No. And every flat earther's favorite auto level, what does it uses? It uses the pendulum on a prism, which is reading the gravity vector. Is it sighting on an ocean horizon? No. So there you go. So yeah, we know that the horizon out there is not a good visual, absolute accurate measure to get a horizontal or vertical angle.
Mm-hmm.
You use the gravity vector because the gravity vector is not affected by atmospheric optics, and anything that is affected by atmospheric optics has to be dealt with and or worked around. And that's why when the Academy of Sciences, Paris, France, in 1760 was questioning whether or not the Earth is a sphere, they measured zenith angles to stars at zenith to where refraction is 0. And they did so on a multi-year, hyper expensive expedition to multiple latitudes of the Earth, and said, you know what? It's not a sphere. It's slightly oblate. And that was proven and confirmed. And they engaged on that because all the surveys across Europe were coming up with these little differences. Not like, oh, it's flat, oh, it's a sphere, oh, it's flat. No, it's like it's 3960. No, it's 4000. Oh, it's 3980. Are you sure? I get like 4100. Oh no, let's go and figure this son of a bitch out. And they measured to stars. And we do that today. And we do that over the centuries. And yeah, you got a black swan photo, you got P900 photos, you got, oh good God, get proper kit, use your science brain and mitigate and deal with the optics of atmosphere.
Okay.
That's how you do it.
Yeah, I hear what you're saying. So, I mean, you know how you're telling us now that we can never see the geometric horizon, it's always apparent, right?
Yeah. And agreed. And that's why we
that
don't
has a
use it.
meaning behind it because
because we also know its displacement is small and never comports with flat.
No, I'm not arguing that. I'm saying that the horizon, for the observer, that's where they have visual. So if a boat goes beyond that horizon, they can get to see the curvature, as in the boat disappears bottom first, right?
Which they do.
Yeah, that's what I'm saying. So at their horizon, that would be their physical horizon because they see physical boat disappearing physically bottom first.
Yeah, and it's displaced optically, but they're both.
No. I'm just saying that
the boat and
I'm
the
just saying that
are
at that point, say the observer's 6 foot, sees the boat going over the horizon, right? So that means the bottom of the boat is lower than his feet. Yeah? You understand?
I guess that was a very weird question. Lower than his feet.
Yeah, so he's standing at the beach. The boat starts to disappear bottom first. So is the bottom of the boat level with his feet?
It's a if you're standing right at the beach and your feet are touching on the water, and the boat is 100 miles away, and you got the water line on the hull of the ship, they're both at the same elevation, sea level. And yeah, I can't see it because it's over the curve. But
all right, fair enough.
Elevation,
yeah.
Constant elevation. The horizon,
mm-hmm.
the hull, the water line on the ship, and my feet are at the same elevation.
All right, that's fine. But let's say now we draw a tangent line to where that boat is disappearing. So that horizon, you're saying, is the geometric one, yeah?
I really have no idea what you just described. A tangent line from where? Because
from the observer at the beach? Let's say from the observer to the horizon.
And I set up a tangent line, yeah. So now the crosshairs of my instrument are looking into the open sky, yeah, because the horizon a couple of miles away will be below those crosshairs, except in the most severe of optical conditions of weather.
Yeah. So those crosshairs is what you would say is straight ahead.
Well, straight ahead, that's kind of, that requires qualification. Straight ahead on the Earth is just straight ahead, because that's why that tangent line is called horizontal, also called the astronomic horizon, but it's not called level, it is called horizontal.
No, let's not use the word level, that's probably my mistake. So you're saying that it's all level, sea level, fine, I accept that. That's why I went to the tangent line. That tangent line...
this one here.
Yeah, with the tangent line there, the boat and the horizon is below that line, right?
Yeah.
So is that a geometrical point then?
Yes, except for the effects of optics of atmosphere, which we know and have quantified and have measured, and therefore there is an uncertainty in the quantities, but we know about how much they are. And we know how much they are by referring to some of the greatest textbooks ever printed on the subject: the Admiralty of the United Kingdom, the Ordnance Survey of the United Kingdom, the Royal Engineers of the United Kingdom. I use them as my reference because,
if I'm 6 foot, Larry,
UK, because I use them as a reference because the UK publishes their experience, publishes their greatest levels of science, just like when they measured the elevation of Mount Everest using the optics that do affect vertical angle measurement, and they still got the right answer for the elevation of Mount Everest while using refraction corrections and the radius of the Earth. And they measured the radius of the Earth from observation of stars. So I'm going to go with the Brits on this one. Okay, you hate the Brits, obviously.
Okay, so what I'm trying to find out, Larry, is that once I've drawn that tangent line, I've got the crosshairs where the horizon is, will that be the same every day?
Nope. First off, what you said was wrong.
What I just said, there are optical effects of the atmosphere that vary with weather. That's why the ocean horizon is not used as a point of reference. Because
no, but I'm just saying, so why do we draw a tangent line or use the crosshairs if you can't make a measurement?
I don't know what the hell you just asked.
So you got your theodolite, you got the crosshairs, the horizon, you've got your tangent line. Will that tangent line be the same tomorrow and every day?
Yes, the tangent line will be the same every single, as consistent within the air budget of the instrument. Yeah, okay, so what?
Well, that's the point. Is that the horizon?
No, the point is, that's the point. That the instruments are mechanically repetitive and good science. And when observing something at distance, in our tabulation, we have to say, oh, and by the way, I was looking through 8 miles of atmosphere. Oh, that has a quantity. with an error budget, and then the instrument has an error that has an error budget, and then we're going through tabulation, and we'll get an elevation measured at a far point with a plus or minus associated with that, which never, ever, ever even comes close to approaching the flat.
I'm not arguing that. You're still just jumping the point. I'm just trying to figure out how we can figure out where. So let's take a look at this mountain picture here, for example. All right. When we send the theodolite looking through it, the crosshairs will be, are you saying, just above that horizon?
Depends on how far. Well, you said a mountain. If you're on a mountain and you're looking out over the ocean, yeah, the crosshairs will be above the ocean horizon.
Just above the ocean horizon. Okay, that's what I'm asking you. So the same is with this image. If we take the theodolite out, we will have the crosshairs just above the horizon. Yeah.
Yeah.
Okay. So so we're going to take a measurement of that, right? And say the Earth is dropping down from that point.
Timo, if that is level, how is that on the horizon? Because the horizon is allegedly dropping away from you.
Well, that's what I'm trying to find out
Not allegedly. Not allegedly.
Measurably.
How is it on the horizon then, you thick cunt?
Measurably, you thick cunt.
How? How can it be level at the horizon if it's dropping away from your position?
There you go.
How?
I think that's
screwed your brains up so bad.
You know, Brian, I'm still going to go with the British accomplishments in geodesy.
Don't give a fuck what you're going to do. The fact of the matter is, if it's dropping away, it wouldn't be on the fucking crosshairs of the level, would it, you twat?
It's not, you twat.
It's not. Yeah,
Fucking
exactly,
asshole.
Brian. Exactly, Brian. When I set up the instrument, and I'm sitting on a mountain ridge, and I'm only at 1,900 feet, and I'm looking over at a mountain ridge that's 2,500 feet, my crosshairs look straight across the top when I'm 28 miles away. Yeah, Brian.
So how do you explain then,
How much drop is there in 48 fucking miles?
Larry, how do you explain?
You got a problem with 48 miles? Good God!
I haven't got a problem with 48 miles. Why the fuck would it be in your crosshairs as level at 48 fucking miles?
No, I said the crosshairs would be above it when I 90 up the gun, and then I measure the angle down to it.
Times 48 divided by 12. 1,536 feet below your fucking position.
No.
It's nonsense. They fucking brainwashed you, thick cunt.
It's 500 feet below.
They have fucking brainwashed you.
No.
Yes, they have.
Brian, you're not yelling loud enough.
They have brainwashed you.
I still got to go.
It's complete and utter fucking nonsense.
I'm still going to go with the British Admiralty.
Don't give a fuck who you're going to go with. You have been brainwashed.
Brian, what model instrument do you use?
Don't give a fuck. It's common fucking sense, which you haven't got.
Okay, Brian. I'm out there with proper kit.
I don't give a fuck. If the Earth is curved, it is supposed to be 1,500 fucking feet below your fucking level point. And it isn't. You've just fucking admitted it isn't. It's nonsense. They brainwashed you. Wake up, man, for fuck's sake.
Below what, Mad Dog?
Brian,
below what?
Brian, check your meds. Brian, check your meds. I think your lithium's a little low. Brian, your lithium.
I sometimes have to go to a shouting mode to get.
There's a very simple point here, and Brian, it's eluding him. But when you're talking about below, that's relative, and you're talking about below a horizontal line from the observer or the surveyor's position. No, Brian, I'm going to put sugar in your fucking fuel tanks if you don't simmer down and behave yourself, young man. Do you understand me? No, we're going to have a conversation here. One person speaks, they finish, the other one yells. And then the other person speaks, and then the other one yells. Got it?
do love you, Curved, I must admit.
All right.
Right.
Below
It's
is
a level
relative, dude.
position.
You need to understand what it's relative to. And this
It's
is the part where
relative
I'm
to
speaking,
your-
Brian. And then you're going to yell back at me after you don't understand the simple example I give you. Put a goddamn level on a beach ball, Brian. That dog. Down, boy. Down.
Shut up, and I might be able to get a fucking
Brian.
word in.
Brian. I'm almost done. Put a 4-foot level on a beach ball, Brian.
Position.
Can you take it from there, Brian?
Yes, and then the fucking ball drops away from that fucking level.
Exactly.
And it doesn't.
Now
It's
put an
just
army man on your beach ball.
there.
Put an army man
Yes.
a distance away. Brian, put an army man. You've got some little dolls, action figures, figurines, whatever. Maybe you collect Hummels or precious moments, whatever it is you have. Place one of those objects on the beach ball at a distance away from the point where the level is resting on the beach ball. Arrange it, so stand it up on the ball so that it's aligned radially from the center of the beach ball, but at that distance away, and then just kind of slide it up until the height of the figure reaches the bottom of the level. Okay, now you see the ball is below the level there. It's at the head of that figurine that you place on it. That's how it's below your horizontal from the surveyor's position, and showing you that indeed the earth does curve away when you're at X number of feet and you are looking level, so to speak, out horizontally, and your line of sight intersects something at a much greater elevation. I'm done. Scream away.
Finished.
Did I fuck that up, Larry, or is that okay?
No, you fucked it up.
Yeah, there's a lot of good approximations. It's exactly what you said there, which is exactly what's in every textbook, which is exactly my experience. And you 90 up the gun. If you're on a ridge, you 90 up the gun, and those crosshairs are looking into clear blue sky, even though there's a 3,000-foot mountain in front of me. In given sufficient distances, yeah, my crosshairs will be. If I'm like on Pacific Coast Highway, 100 feet above the water, and I 90 up my gun, my crosshairs are looking into clear blue sky by a couple of degrees. Yeah, it never gets to be flat. Yeah. And when I get right down next to the water, all hell breaks loose because of the optics of air. And that's why surveyors don't put the crosshair on an ocean horizon and call that anything. We don't do that. Even a carpenter doesn't do that. Brian does not even have the comprehension of how to use a carpenter's level. No. And again, the Brits, I put this back when I hear Brits slam flat Earth, and I got to say, you're only a couple of miles away from the Greenwich Observatory, you idiots. The Admiralty charts of the entire world are so highly prized that the entire globe came to consensus will let Greenwich be zero because they fucking invented it. Harrison invented the chronometer for determining longitude based on the shape and speed of rotation of the Earth. Yeah, the Brits, they when they measured Mount Everest from 100 miles away and took a year to calculate the answer, they got the right fucking answer in 1865. And it's been replicated by satellite data. We have satellite data. We have satellites, polar orbiting satellites. Yeah, right. So, yeah, you place it up a straight edge or a level on a beach ball or a basketball, and that is horizontal at the tangent point and nowhere else. And yeah, as you go away from there, yeah, you will soon be able to put your little plastic army man completely under that level, yet the army man's feet and the point of tangent are the same elevation in beach ball units. Same elevation. That's the definition of level when used in the context of surveying and the shape of the earth. Now, they get confused, particularly Brian and Bev, because they are the lowest of low. Is that they say level is horizontal, right? Well, you know what? Because for a couple 100 feet, they're indistinguishable. Horizontal and level for a couple 100 feet is good enough. If you want level, like to lay your concrete forms or build a building, yeah. If you set up a level and you read from horizontal, you're going to be so freaking close to a constant elevation, it won't matter. And that's why you use it, because it's easy and practical, accurate with a known accuracy and limitations. And if you're going to go out there and measure the height of a mountain or an obstruction to navigation, like a radio tower or a military asset that may be 20 miles away and on a ridge, like a radar dome that you need to take out with guided missiles, yeah, you're going to set up a theodolite, you're going to measure the angle, and you're going to calculate the elevation above sea level, not the plus or minus from my local horizontal, because that would be meaningless when dealing with many miles. When dealing with a few 100 feet, yeah, there's not enough difference. But if you're building a LIGO, if you're laying out an experiment at Fermilab, if you're laying out a magnet alignment in the LHC, you're goddamn right that 1/4 millimeter and a few 100 feet matter. If you're laying out concrete forms, it doesn't. So that's why a level, an auto level, a surveyor's level for a couple 100 feet, horizontal and constant elevation, are pretty damn close. I mean, come on, who cares about a 1/4 millimeter when you're laying concrete forms or just building a building, right? But when you are out there trying to determine the elevation of an obstruction that an airplane might hit, yeah, or if you're confronted with 10 miles away, 15 miles away, you're not just going to quote it's plus or minus from your local horizontal, because that would be meaningless, wouldn't it, Brian? Yes, it would be meaningless, because that would be stupid, ignorant, irresponsible, and does not comport with reality. So instruments measure against reality. Computation keep you in reality. And it doesn't matter where I put my instrument, I get the same elevation when I apply the 8 inches miles squared, knowing that I have another 1.25 inches for the miles squared that is affected by the optics of atmosphere. And I can carry that out for 20 miles, 25 miles, or 5 miles, or 1 mile, and I get the same consistent answer. But I get very inconsistent, grotesque inconsistencies if I ignore curvature and refraction. But they're not that inconsistent when analyzed, and you find, yeah, it's a curve. It's a curve of 22 arc seconds per mile. Yeah.
But look, again,
yeah, there you go, Brian.
When you send your theodolite out, crosshairs above the horizon, if that's above the apparent horizon, how are you making any measurements?
Oh, do you not take notes from the gravity vector? The same gravity vector which aligns an auto, the same gravity vector which drives a carpenter's level.
No. I'm asking about when you put the crosshairs above the horizon. How do you know that that's the physical horizon?
I don't know, and I don't care. I never use it. I never make reference to it. It's material.
No, but you said from the crosshairs, the horizon drops.
Yeah.
So how do you know which horizon drops?
Full of shit, man. Absolutely full of shit.
How do you know which horizon is dropping? Is it the physical one or the apparent one?
The apparent one is the physical one displaced by optics.
The apparent one is the physical one, did you just say?
Displaced by optics. You can't use half that sentence.
I don't know what that means.
You can't use half that sentence.
It means you can't see it, but we know it's there.
Okay, and that's why we don't measure from it. We absolutely agreed on that point, and that's why we don't use it in measurement.
No, but you're putting the crosshairs above the horizon and saying that the horizon's dropping from the crosshairs.
I don't put the crosshairs anywhere relative to that horizon. I put it perpendicular to vertical. The crosshairs will be above an ocean horizon, sometimes a little bit more than others due to atmospherics. But the fact that the horizon is displaced by optics, I don't care where the geometric horizon is. I make no reference to it. I make the reference from vertical.
But then how are you getting the vertical or drop or that direction if it's never going in that direction?
Because they make this shit up.
That's a broke.
Yeah. Chemo's making up some shit. He can't even make a coherent question.
You keep talking about vertical vector, yeah?
The gravity vector, which is radial to the Earth. Yep.
Yeah. So you're introducing something that you haven't even accounted for. What I'm saying is that you look at the horizon with your crosshairs, and you're saying the Earth is dropping down beyond that point.
You can
only from the horizon, my local horizontal, which is unique to that specific instrument location. Yeah.
Well, that's the point of the Black Swan, is saying that it doesn't do that.
Except we have discussed the ambiguity of photography in those environments as being so noisy and ambiguous, because you got the Black Swan photo and there are photos taken from the identical location which show a different scenario. So now we have two scenarios. Which one's right? Okay, we have to discount photography taken close to the water because of the optics of atmosphere. And that is why geodetic surveying doesn't use landscape photography and P900s to define or deal with a 3,960 mile radius of the Earth. It takes better kit. It takes better environmental considerations. And that is why we measure from the gravity vector and we access the stars, because that maintains the accuracy. That is repeatable science. You want repeatable science?
Right, you're missing the question, Larry.
You cannot take the Black Swan photo 2 days in a row.
Larry,
that's not repeatable science.
Beyond the horizon, is the Earth dropping away?
No, because the word "dropping away" is an ambiguous statement. I can't address that.
So it's not dropping away. Is the Earth beyond the horizon curving away?
It's the shape of the fucking planet. Yeah.
So beyond the horizon, you're saying the Earth is curving away.
I would never use the phrase "curving away" in a sentence. It's
all right.
The shape of the
So
planet.
tell me then, explain to me then, what is happening beyond the horizon?
More Earth.
Yeah, more Earth.
It's curving away at your feet. It's not curving away at the horizon.
That's not where it starts.
I didn't say where it starts. I didn't ask any of that. I didn't ask about where it's curving everywhere. I didn't ask about where it starts. I said, what is happening beyond the horizon?
The same thing that happens before the horizon.
Which is what? What is what? Which is what?
Curving. It just
well, Larry didn't say that. He just said more Earth.
He answered your question.
He didn't say that. He didn't say what you said.
Hey. He answered the question you asked.
No, he said no, it's not dropping away. It's not curving away.
Because that's a loaded question. You've been playing that game for 6 years.
It's a very simple question. Beyond the horizon, what is going on?
Get honest answers. You were told. The answer to is it dropping away needs to be qualified. Dropping away from what?
The horizon. Duh.
Local horizontal.
What do you mean? I've just said about 5 times. Now, Larry, beyond the horizon is the Earth dropping away.
Made that point very clear.
Well, again, I've said it 5 times. Beyond the horizon, what is happening? Is it dropping away, curving away? What's going on?
Chemo's getting restless. He needs a shit show. Go ahead.
You see?
Keep stirring the pot, Chemo.
Not from my position. I said from the horizon. What is going on? From the horizon.
All right, get down on all fours so that you can see it from Chemo's position.
There you go. So that's why I come to Flat Earth, because you can't explain what happens beyond the horizon. You don't want to say curving away because you know it's not curving away because you know that horizon moves all over the place.
From a tangent or from horizontal, it absolutely is.
When I did answer Chemo, when I did answer your question, and I said, yeah, it is dropping below my local horizontal, and then your immediate response was to come back with only half of that answer, and then so you like to cherry pick even one fucking sentence. You couldn't use the whole sentence, so that's why there's no point in dealing with your circular, illogical, hyperbole, because the shape of the Earth is too fucking obvious. We can talk about dimension. But
again, all I'm asking is, after the horizon, what is going on?
Okay, and I'm not going to answer that because it's a silly fucking question, and you're being
I wouldn't
silly.
answer it if I was a global either, because we know the black swan has destroyed your possible response. That's how powerful the black swan is, Larry. That's the point of the black swan.
Hold on.
And what is Blackpool doing for you, huh?
Gives us another Blackpool swan. We have a Blackpool swan in the left of the image.
I want to make a point on that. Chemo, look at a soccer ball. Can you see the entire soccer ball? Yes or no? You're just looking at it.
Make your point.
Did you answer?
Just make the point.
Okay, there's a limit to how much of the soccer ball you can see from wherever you're standing looking at it. What's going on with that soccer ball after the point where you can't see it anymore?
You just debunked yourself, you dumb fuck.
What's going on with the rest of that soccer ball?
I don't know.
You can't see the soccer ball because it's a fucking sphere.
I'm talking about when Larry measures the horizon dropping away from his
He's not measuring the horizon dropping away. He made that very clear.
The horizon is below his crosshairs. So I'm asking him what's happening beyond that horizon.
Obviously
you
below
don't have
crosshairs.
The other light, like Larry
QED. Now, Chemo, what's going on with that soccer ball past the point?
I have no idea. I'm talking about the Earth.
You don't have a clue, do you?
Well, put a crosshair there and I'll tell you.
Are you this dead?
Put a theodolite on it and I'll tell you.
Chemo.
You don't need a theodolite.
You do need a theodolite for surveying. Survey the ball. Survey the ball.
Beyond the point you can't see, just like it does on all the surfaces that you do see.
Yeah, well, survey the ball and we'll tell you if there's a drop or not.
They're
You're pissing your pants.
They're distracting.
So Larry, at that horizon with your
crosshairs, it's so easy.
It is so easy.
Chemo, I just put up a graphic in the chat. Could you take that apart technically? I mean, keep in mind that's going to be the Royal Engineers you're going to be dealing with.
No, probably not, Larry. Look, I'm just a regular guy asking regular questions. Now, beyond the horizon, Larry, what is going on?
Hold on, we got to get something straight. These Royal Engineers, are they a step above the Girl Guides?
So, Larry, what's the deal with the horizon? Is the Earth physically dropping away after the horizon?
That was an important question, Chemo, and you're just sidestepping it.
No, you're just saving Larry from embarrassment.
It's just dropping away beyond the horizon the same way it is before the horizon. It's a radius of 3,960. So if you can't, you can answer your own question, but you don't want to.
Larry's a surveyor. Very simple answer.
Easy fuck. He's acting.
What goes on beyond the horizon?
These are just voice actors.
What goes on beyond the horizon is, as was pointed out,
they know a little bit about the subject that they're going on, that they're acting out. Other than that, they are just actors. Take the notes of the cunts.
Beyond the horizon, Larry, what's going on? Is it getting lower and lower and lower? Does the Earth get lower than the horizon, Larry? Beyond the horizon, is the Earth and the water and the land getting lower and lower than the horizon, from the horizon?
What do you mean by lower? Can you explain what you mean by lower?
I said Lala. So, Larry.
Can you explain what you mean by lower?
I said Lala was.
You are in Lala.
Exactly. Now, Larry.
So what do you mean by lower?
I said
what do
Lala.
you mean, does it get lower?
I said Lala.
Yeah, you can't. You see, you're so scared you can't answer the question.
I said Lala.
You can't answer the question, can you?
I just did.
What do you mean by that?
You're worried, mate. You're worried that you can't answer it because you don't have one.
What do I mean by what? Lala? That's Aussie talk.
What do you mean by that?
This is pathetic.
Precisely. Now, Larry, the expert,
Yeah, you're a
surveyor.
sad man, Spurs, when you do this.
See, they're all
You're pretty
saving you,
sad when
Larry,
do
from
this.
embarrassment. All listen to them.
What do you
panicking,
mean
okay?
by lower?
So, Larry, at the horizon.
Why don't you ask him, Larry?
What happens beyond the horizon? Is
The
the
now
Earth
you've
dropping
changed.
away?
Before, as was pointed out, the same thing happens before the horizon. It's a continuous smooth arc. I don't know what your fucking deal is.
Well, so I'm asking you, is it from the horizon? Is the Earth dropping away?
The same way it's dropping away from me. It's a continuous arc. Does
Yeah,
the word continuous arc? Is the word continuous arc like too weird for you?
So that's what I'm asking you. That's why I presented you a picture. Let me show
Does
you
the
this.
beach ball drop away from the straight edge?
Did you look at the graphic I posted?
I did,
Please
yeah.
do.
I've got it on the big level is constant elevation. Yeah, I've got it there. Yeah. Now look at
Spurs,
my
do you not
picture here.
understand his answer? Is that the problem? Are you not understanding his answer?
Probably not. That's why I'm asking more questions. Look at this, Larry. Did it load? I don't know if it loaded.
Probably.
Oh yeah.
You don't
Look at this
understand
image.
much.
Now, beyond that horizon, what's going on beyond that horizon there?
Well, you know what? That's again a photograph taken from very near water. So there's a huge.
No, that's not at the water one.
Oh no! You wait. There is a huge corruption of the visual capture of a camera.
Yeah.
Therefore, it does not return significant information. Therefore, it's not worth investigation, except in the investigation of the corruption of atmospheric optical effects.
I hear what you're
And
saying,
that's
Larry. I hear what you're saying. Now, remember the first one that was
apparently you didn't. Otherwise you would realize everything you said is stupid.
maybe so, Larry. But the first black swan you saw was with the bendy cranes. Remember that one? That was right on the ground. Then what he did, he went back again and went a little bit higher. I think this is around 12 foot or so. He's on he went up. He's on this. He's on the concrete basically. This one's not at the beach. Because the first one at the beach was giving us bendy cranes. You said it's too low. Now, this one that I've just posted does not have the bendy cranes, you see. It's a bit of a higher elevation. And the same thing happened. What we found, Larry, is that if you put the crosshairs above this horizon and wait till the next day, the horizon rises up, Larry. Let me show you
Which
this.
we talked about earlier, yes, atmospheric optical effects, which is why when it comes to measuring the shape of the Earth, defining the shape of the Earth, dealing with the shape of the Earth, yeah, optical effects of the atmosphere make very low elevation photography and geodetic measurement impossible when you're trying to measure to an ocean horizon, which has no point, purpose, use, and nobody does that. So you're using your P900 photos to come up with a way that not even a carpenter would do. A carpenter would go like, why would I line up my level to be even with that ocean horizon or anything about that ocean horizon? I have the gravity vector right there in that little alcohol vial. That's what I'm going to use. So why would I there's no point in terrestrial photography, especially close to the ground, because it's ambiguous. And you get all kinds, as you said it yourself, you go out 2 different days, you get 2 different photos. You know what that means? Both photos are pointless.
Well, that's been our point, Larry, the longest time, is that when we see ships disappearing, mountains or platforms obstructed, it doesn't mean it's the Earth curve. You have to go much, much higher, right, Larry? Larry, drop out. Larry?
I'm sorry. I thought you had an intelligent question. Yeah, when you see only half a ship and there's the ocean horizon in between you, yeah, it went over the curve of the Earth, of the horizon, because it's so far away that half the ship is obscured by the ocean in between because of the shape of the Earth. That's not that fucking hard. And on some days, yeah, there's going to be optical atmospheric effects, which is going to affect at what distance that happens or corrupts the image in some other way. But it doesn't matter. It doesn't matter because we measure the Earth in far more accurate and precise ways, far more consistent.
But you said that the ship would disappear
Repeatable
bottom
science.
first. It doesn't matter which horizon. but they're all Earth curve. Every horizon it disappears over, they're all Earth curve, is what you're saying. So this image, this platform image, if the boat goes over the image on the left, that's physical, you're saying. And then the next day, when it goes over on the right, that's still physical Earth. It doesn't matter what horizon it goes over, to you it's physical curvature, yeah?
I don't use optical photography, so I'm not going to talk about optical photography. The refraction of a theodolite measurement, that's different, and that's an ambiguous environment. So I'm not going to attempt a repeatable science in a high noise condition. So I don't care what goes on in that photography. I don't care which platform appears elevated on some days and not on others. I can only see half a platform today, and now I see 3/4 of a platform tomorrow. I don't care. I don't care. I know that is a predictable outcome, and it's ambiguous, so I don't care. I use more precision, more precise methods, much like that which is put out by the Royal Engineers, the greatest surveyors of all time. But if you have a problem with the Royal Engineers, bring it up with them.
No, I'm just saying to you that you're saying in one breath, we can look at boats disappearing and trust that it's the Earth. But when we look at this observation with half the platforms, we can't be sure if it's the Earth or not.
I don't care. Somebody else is going to have to take on chemo.
Another one bites the dust. And it's simply because the Black Swan sends every surveyor, anyone who does geodetic surveying, anyone who uses theodolites, they're in a world of trouble because they've got to answer what is beyond that horizon. Does the Earth drop away at that horizon? And if that person says yes, well, they're in big trouble because then they have to explain the Black Swan. How does the horizon move? Then you've got to include optics, refraction, like you say. And then we've got to ask you, okay, that's fine, then which one is the real horizon? And then you're going to go around and say, well, we don't know. And then we're going to say, but you said the shit went over the horizon. Is that the physical geometric horizon? You're going to say, yeah. And then we're going to say, well, hold on a second. So it's going to go around. That's why you guys, your head is in a bit of a muddle. That's why it's so confusing for you.
No, we abandoned that whole avenue because of its imprecision.
Yeah, this is confused PhDs, this image. It's like Tony the PhD said, this is refraction of a different character.
Not a legitimate PhD.
Tony on Fight the Flat Earth. PhD Tony.
Okay, I'm going to quote Jeremy because Jeremy put me onto a really nice, brief technical document. He said, look at Andrew Thomas Young's work. And so I did. And it's like the best flat earth debunker ever. And Jeremy is citing him. So I'm going to go with Jeremy on this. Is that okay?
You can do.
I'm going to go with Andrew Thomas Young, who is a PhD and has pointed out the optical effects of observing a horizon, dip to the horizon, all that good stuff. Now, I'm going to yield to that PhD because Jeremy brought him forth.
Again, not a problem. Then I have to explain what's happening beyond the horizon. Is the Earth dropping away after the horizon, or is it the same, just going straight ahead? Or does it curve down?
Continuous arc.
Down, yeah, beyond the horizon, yeah?
Continuous arc.
Yes, that's how you imagine, but I'm on about in reality.
Continuous arc.
So then how do you explain the Black Swan then?
Through the optical effects of atmosphere in extreme conditions, which causes ambiguity, and that avenue is not used in geodetic science.
Then how would you know where any geometric horizon is then, if after what you just explained?
Don't care, because I measure from the gravity vector.
Gravity vector. Okay, you want to talk about gravity? I mean, you're including things that you can't defend, Larry. That's the point of your position. You just bring up buzzwords, gravity vector. I mean, what on earth is gravity? Have you tested gravity? No.
Plumb bobs work, and 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 all the little alcohol vials and the carpenter's levels work, and the orientation of an auto level is based on the gravity vector. So yeah, I'm going to go with that.
You're going to go with the presupposition of gravity and a ball. Well, that's a religion, Larry. Not real science, not real measurements, you know?
You know, if I even thought you believed what you just said, that'd be different. But you don't. You're just a Poe.
Well, Larry,
shit.
The audience will decide that by me asking you questions about your measurements. They will decide if you're the Poe, if you're a real surveyor, or if you just have a religious belief. Let that sink in for a minute. Let's think about that for a moment. We're still here, audience. We're just thinking about Larry's religion for a minute. We're still here. Don't panic. We haven't gone anywhere. It's not an awkward silence, everyone, and audience. We're just.
All right, I just put up a graphic. Why don't you take that apart technically? Find a problem with that technically and be specific.
No. Again, I don't have the expertise in these things. You're the expert, Larry.
Nope. And I'm demonstrating. I brought forth my measurement data with my instruments. Find technical flaw with it, specific, and be very fucking specific.
Mm-hmm. Thank you, Anthony, very much. Shout out, Anthony. No, we'll talk later. But the point is, as we continue, Larry, yeah, I'm not an expert, as I've said. I don't profess to be wise or anything like that. Just a regular guy walking the street, searching the truth, looking for experts to explain to me or show to me that the Earth is actually curving. Now, obviously, other people have brought forward this black swan, which shows the horizon not physical. Therefore, if it's not physical, then how are things dropping and disappearing away beyond it, right?
Well, I like the fact that you laid out your qualifications as being zero and dependent on the opinions of others. I brought forth a technical measurement that I performed. Would you please reach out to somebody and find technical flaw with it?
Well, like I said, do you have a practical technical measurement?
Yeah, I put up my own work right there in the chat. You got a problem with it?
Does that include the atmosphere?
Yeah, because we don't live in a vacuum.
Okay, so it shows you that does your image show that you cannot have a physical geometric horizon?
Physical geometric horizon is just nothing that ever applies to any part of measurement science.
What it just means is if I'm a particular height, I can calculate how much of a mountain or object I should or shouldn't see based on the geometry of the Earth, right?
Based on geometry alone.
That avenue's been discussed. I'm not even going to engage in that. I put up my own measurement to find technical flaw with that measurement. Why is that tower that's 27.69 miles away? Why is it 400 feet higher in elevation and below my local horizontal?
That would mean it's a ball, it's a globe by your model. But I'm talking about the real world, okay?
The real world has satellites that orbit. The real world has 24-hour sun at South Pole.
None of which we can demonstrate to be true, yeah?
Oh, yeah, no, we do.
None of which we can demonstrate practically, Larry, yeah? Now, I understand the model. I understand you have a model, you have a working model.
The South Pole is a unique, specific point on the Earth
On the
that
model.
experiences 24-hour sun. We're done with shape.
Yeah, and it is the winter there, so they're actually having 24-hour nighttime down there. So does that count?
Okay, look, Larry, again.
No, hang on, shut the fuck up. Does 24-hour nighttime, does that count at the opposite end of the
What
seasons?
doesn't happen,
Does that
Jezza?
count?
That's the model.
No. Does that count that they're having 24-hour midnights down there at the moment?
That would make
in
the
the middle,
Earth a ball.
in the middle of winter.
Everything you're
No,
saying.
hang on.
Make it a ball.
Chemo, shut the fuck up. The opposite of the sun in the summer months, all you guys say that there's not 24 hours of daylight in Antarctica.
Mm-hmm.
They're now having 24 hours of midnight down there.
Okay.
It's the middle of winter. So does that not count?
That would make it into a ball, yeah?
No, I'm not saying that. I'm not saying any shape. I'm saying summer. There's supposed to be 24 hours of daylight, which there is, but now there's 24 hours of daylight. There's 24 hours of darkness. Does that not count?
Okay. What's the conclusion, though, Jezza?
I think that was a question. Does it not count?
Yeah, I guess. It'd make it a ball, is what you're saying, yeah?
Well, some dingleberry fucking banned me. So does 24 hours of darkness in the middle of winter? January 22nd, that's the winter solstice.
Yeah.
So there's 24 hours of summer and the 24 hours of daylight in the summer.
Okay.
Now there's 24 hours of darkness in the winter. Does the 24 hours of darkness, does that not mean anything?
Yeah, I guess so. It would mean it's a globe.
Hey, I never said that.
Look, we're on a globe. We're trying to figure out from Larry if the horizon's physical. Therefore, if it's not, then we're back on a flat Earth. So right now, you've convinced me, Jazza, we're on a ball. Now, Larry, you're the surveyor. Are we able to measure the drop after the horizon there?
I never convinced you of anything.
Oh, you did.
Is not saying the Earth is a globe. He's not saying the Earth is a globe.
Yeah,
I don't
it's
even
a ball
know.
spinning, flying through space. Let's start from that start. Let's hypothesize about. Let's start from that starting point, right? We all agree we want a ball spinning, flying through space.
Past
Now,
that.
we need to figure out, Larry, from an observer, where the Earth drops away. Okay? So, did you make a measurement that shows after the horizon, the Earth is dropping away?
Chemo, can I just interrupt just very quickly? It has
Seconds
nothing to
away
do with
from becoming a glober. We're going to have a practical demonstration from Larry.
This is a practical demonstration. I have no qualms about the shape. If not, I do.
We need to know if we're spinning, flying, or if we're on a flat and stationary plane. It's important, right? Because if it's a flat stationary plane, that means there's something outside the dome, right? But if we're in space, and with aliens and stuff, that means we could go to different worlds. So we need to know what we need to work on, right?
It is important. And Chemo, this is what I just want to ask you this question.
Okay.
Very quickly. I personally know that I can go and have a beer with tomorrow.
Alright, sorry about this, Larry. I can't help that the drunks have shown up and are trying to derail you from answering about your surveying stuff. I apologise, but we'll try again. So,
Okay. I put up my measurement in the technical document. Do you have specifics, problems with that? The tower is 400 feet higher, 28 miles away, and below my local horizontal. That is my measurement of drop.
But you had a horizon. There was a horizon, and you were saying the Earth was dropping beyond that point.
No, I have a local horizontal. I don't use the horizon because the horizon is not optically presented to me in sufficient accuracy, so it's not used. Unless I'm confronted with using a sextant, I always use the gravity vector.
Yeah, exactly.
When you say gravity, you mean a plumb bob, yeah?
I mean the same force which drives a carpenter's level and a plumb bob and an auto level.
Yeah, but to be fair, you can't really use gravity until you have an experiment, right?
So not true. Not true.
So if your instruments require gravity, all of your results are null and void.
All right. Why don't you show me that a plumb bob doesn't work? I've shown you a plumb bob does work.
Yeah, Chemo's saying levels can't be used now. Everybody throw your levels away.
No, I'm saying you can't include gravity. If you include gravity, everything is null and void. You see?
Yeah, so a carpenter can't trust his level because unless he goes through and starts from first principles and makes his own
a carpenter relies on relative density disequilibrium.
Oh, fuck you! Fuck
Hang on.
you!
Hang on. Hang on, Chemo, shut the fuck up. Larry, so you're saying, and I get what you're saying, is that everything that you test as level is perpendicular to the center of the Earth.
Radial to the center of the Earth.
Yes.
Plumb bobs hang radial, and plumb bobs are not parallel by a factor of 26 arc seconds per mile of separation.
Yes.
Proven, measured, demonstrated ad nauseum for centuries, including by the fabulous Brits when they determined the elevation of Mount Everest from 100 miles away and got the right answer.
And they did. And one thing I was going to say to you, Chemo, actually, you said Mount Everest, Larry, is Chemo, is you could be standing on the most awkwardest angle on the center of Mount Everest, but if you were standing straight up and down, the point that you were standing on is a datum point perpendicular to the center of the Earth. That's why you don't fall over.
But again, sorry, Larry. I apologize for Jazza. Okay, so Larry, again, your measurements, we have to review them because you're including gravity. So you're assuming that the plumb bobs will have a deviation, and you have no experiment of this force causing this deviation, right?
You need to check your meds. You know we live on a planet, and the planet has dimension.
Not about what I believe, or it's about what you can demonstrate, Larry.
I demonstrated. I brought it forth. I put it on the chat. Show me your conflicting measurement with proper kit.
Larry, you just posted a piece of paper. Post a video of you measuring the drop, the horizontal.
Chemo.
Yes.
Chemo.
Yes, just.
Okay, so
apparently you can't use a textbook. You have to only watch videos. Is that it?
You've either got to show a video or
apparently, if it gets written down, it's no longer true.
No. You write it down after there's a physical demonstration or a practical measuring tool that's in place, like all the time, so we can go and check it, verify it, all those things, right?
See, Larry, GPS, I don't know if you can hear me or not, but this is why I think I think these flat earthers are crazy as fuck. Like fucked in the head.
No, what I've heard from Larry is just trust.
Hang on, no, chemo, because what you're saying is that I need to have a measuring tape and take it from where I am right now, and unless I can take it from where I am right now from my doorstep to the fucking moon, then that proves that the moon doesn't exist. Is that what you're saying?
Have lasers. What are you talking about?
Oh my fucking god! Make up your mind, you dumb cunts.
Anyway,
Jesus
look, Larry.
Christ.
The idea is that you've been hoodwinked because you're basing your measurements on gravity, which you know there's no force. You can't demonstrate it. You don't just drop things and say, "Oh, there's gravity." That's not gravity, Larry.
Well. Oh well.
Pause,
Hang on.
Pause.
Sorry, go ahead, Larry.
Pause. I just put up a video of me measuring it.
Yeah, I can see it. I'm watching it.
Oh, good.
So,
I
you want to see, Larry.
heard Chemo say something about lasers.
You want to see real world
Chemo, what's this about lasers for the moon?
What?
You just said something about the moon and we got lasers. What, to measure the moon?
Larry, you're not going to copyright strike. Can I put this on my channel, this video? Can we watch it?
How about you just watch it here?
I'm watching it now.
Yeah. Yeah, let's just watch it.
Yeah, I'm watching it, and all I see is the theodolite on a hill, looking across some hills. Okay, he's going left, right. He's looking. Let's forward. We've got this there.
And Chemo, have you got? Chemo, have you got any experience? There's thousands of that.
No, hold on a
out
second.
there.
I'm just reviewing Larry's work here. So, Larry, this is not really making any measurements here. If we look at your work, all we see is you using your phone to look around the theodolite. Now, remember, you just told us looking through optics cannot give us accurate measurements, right?
I believe he's telling you what he's doing. Do you have the audio turned on?
Oh yeah, no,
I don't think he does.
I've got it on mute. Yeah.
Well, you probably should have it on mute. Videos you shouldn't watch.
Hey, Chemo.
Oh yeah, I've got the subtitles on now.
Chemo. Hey, Chemo. I didn't see a video of someone taking a video. So videos are no good because I don't have a video of someone making a video.
No, I didn't say that. I was saying a video of the actual. So what you've got is you recording you looking through an optical device. Yeah, assuming that gravity is pulling the plumb bobs down with a deviation.
Hang on.
Yeah?
Chemo. The same optical device that you claim to dragon fucking vessels that have gone over the horizon. So
Larry, this is not how you make measurements, Larry. You've been hoodwinked. Okay?
No.
Now, if you want to make, if you want to measure if there's
Chemo, you're offending me by pulling on the wrong person.
No, I'm saying to Larry, this is not how you would make measurements of curvature.
Okay. Here's the problem. You asked for practical measurement. I showed you its documentation and documentation of making those
I'm watching it now. I can see this is not measurements.
Okay. Find technical flaw. Describe what part of that is not, and don't say plumb bobs don't work, because I don't know why a plumb bob works, but everybody here can repeatedly use a plumb bob and get the same fucking answer. So that's demonstration plumb bobs work. All I need to know is plumb bobs work.
Yeah, and you're saying the other plumb bob has a deviation based on gravity.
No, they hang radial to the planet, and we know the planet's shape.
You see, another to the planet. That's another presupposition.
No, the South Pole exists.
Oh my God! You see, this is what we're dealing with here. A religious person who just says things because they are, just because they are. Larry, that's not being honest.
The South Pole does exist.
No, it doesn't, Larry. There's an ice wall around the edge that keeps the water on.
Okay, now, we have evidence.
No picture of it. In my opinion, we have
plenty of evidence.
I'll see the video.
In my opinion.
We have plenty of evidence of the.
You don't get to have an opinion without a fucking video. That's your rules, not
No,
mine.
I've never been to the ice wall. I'm just assuming that because there's all this water
on
the
up about
Earth,
it.
it's
If you
got to
don't
be
have
held
a
on
fucking
by
video
something.
of you at the ice wall, don't talk about the ice wall. You got to have a video of it. That's your rules,
I assume the water is held on by an ice wall.
And we are
presupposition
the plumb bob.
Yeah, I'm presupposing an ice wall, but I'm not saying it doesn't require. You're saying a force.
Presupposition with nothing to back it up.
You're saying a force is holding the water on. Exactly.
Okay, so what is keeping the water?
It's being contained by, I suppose, an ice wall.
Okay, Okay. I got that. So what instead of gravity? What do you have instead of gravity?
Oh my god! I've just told you, an ice wall.
So, Chemo, what's wrong with the technical aspects of what he's doing? He's telling you what he's doing. He's describing it. He's telling you in detail about how he's doing it. He's not actually showing you through the optics, but he's describing what he sees.
I'm still watching it. Yeah, I'm watching it now. But the thing is, he presupposed gravity.
No,
Okay, so the plumb bob.
The thing that makes the plumb bob orient itself is there. That's a fact.
No, they won't deviate because there was no curvature.
That's fine.
Okay, he's not deviating, but he's going straight. Yeah. So what force is keeping him straight?
Yeah, I don't think he's doing a reverse zenith measurement here, is he?
No, what he's doing is just showing us how much curvature. He's saying there's curvature with these theodolites, and he's presupposing a planet and presupposing gravity.
Kimmo, what force is keeping the plumb bob down?
I can't hear.
What force is keeping the plumb bob down?
Relative density disequilibrium.
Okay. That's fine. We'll use that.
Okay.
Now,
we'll use it. No problem.
That's right. Give up gravity, guys, and forget about that, and understand it's relative.
Okay. The plumb bob is down, and it's showing the vertical. Yeah.
All right.
Okay, so go from there. Go from there. Doesn't matter.
Right. So we're giving up gravity. So that now means that Larry's measurements are flawed because he included gravity in his calculation.
Nope, Chemo. He still has down.
No, there is no down. There is no downward bias. There is no down.
No, he found down. Do you disagree that plumb bobs point down?
What do you mean down? What is down?
Down, the opposite of up.
Which is where?
You're stuck, aren't you, Chemo?
It's relative, Moyak, right? It's relative.
So let me ask this.
Pushed in a corner, Chemo.
You don't know what down is, Chemo.
You're getting pushed in a corner, aren't you?
Me?
You're in a problem now, aren't you?
You think so? Based on Larry's presuppositions,
now you no longer even know what down is.
Find ourselves in.
What's up, Chemo? What else is it you don't know? Do you not know what the trees are anymore?
Now remember, the globe experiments are based on presuppositions. Most of them, if not all.
Presupposition, dang.
You start with the hypothesis, not the observation. Yeah?
Chemo, he have a plumb bob. The plumb bob is going down, yeah?
It's not going down. What is down?
So you don't know what down is.
Gas is moving all directions. Okay?
You've boxed yourself in so far that you can't admit.
No, because if you say down, it means there's a bias downwards, and there's not.
No, it means that density equilibrium sets something up. It sets up the vertical.
Well, again, there's no down because there is no down. Things move in all directions.
Okay, so there's no down.
And there's no relative density.
Yeah, there is relative density. That's why there is no down.
Can't be. If it doesn't show down, then there's nothing to your relative density theory.
Unless you want to go by, like, you're on a flat plane and there's only one up and one down, if that's what you mean. So along the plane, forever, the plane's infinite, there was only one way down and one way up.
No, that's what we're measuring.
I put a couple more graphics in the chat of me measuring. So I don't know what the hell's wrong with you. There's no figuring it. Your lithium must be way out of balance.
Yeah, so your crosshairs that you've got here, you're saying the Earth is dropping away below those crosshairs, right? Have I got that right?
I'm measuring it. So,
Larry, we're going to have to discard your measurements because you're presupposing gravity.
Okay, when you say the presupposing gravity, you are obviously just being satire.
Right, look at your image, right? What's the distance to that mountaintop or wherever it is?
Over 20 miles.
Right. So we know that things in the distance will tend to look like they're dropping down. They sink. Yeah?
Oh.
Yeah, that's true. We know that through with Ranty's
and the
picture
problem,
of the
but the problem is they go down 26 arc seconds faster than your trigonometry simple trigonometry.
So it looks like
We
it's
have-
going down conforming with the globe model. That's fine, but remember, physically, it doesn't actually curve down beyond that horizon point, right?
But you're wrong. Physically, it does. And
No,
reality
not
proves it.
geometrically, Larry. That's oh my god. That's the whole point of the black swan, is showing you don't have geometry.
Well, the point of the black swan, there is no point because it's ambiguous. It is optically affected by the atmosphere, and from the same location, you get conflicting photos. So photos are set aside as not good, repeatable science.
No, your image here is the same thing as any other observation. You're looking at.
No, you just asked for more and more demonstration of me actually doing it.
No, you don't need to do anything more. I've got your video.
I showed you the results. I showed you the results of the measurement.
Mhm.
I showed you a video of me making the measurement, and I even showed you photos of me looking.
No,
through
no.
the
All I
instrument
needed was the
and
video.
how
That
the
was it.
instrument works.
That was it. I got the
so
video.
What have you done? What have you done? Show me your conflicting measurement. Show me your conflicting data, and not a terrestrial photograph of the black swan.
What we
you
did.
didn't even take.
I haven't got the
even
video,
take the
but I'll
black
get it.
swan.
I'll look for it. What I did, I went down to St. Bees, okay, to measure a lighthouse to see if it was visible and comporting with the globe model. Now, what we found, Larry, is that the lighthouse was visible from a given height that was not supposed to be seen on a globe. Okay, that's what we do. We go out and find out if your globe model comports with reality. Now, in reality, Larry, you can see the lighthouse in reality. On your model, you cannot see the lighthouse. You understand? That's the difference, Larry.
How carefully did you include refraction? How carefully was your elevation measured? How carefully is that distance measured?
Oh, very carefully, Larry. We went out there and we made accurate measurements.
Okay, very carefully. You mean centimeter?
Video of it, right?
I'll have to get it, yeah. So we'll get that for you.
Yeah.
Soon.
Need to see video of you making those measurements, Chemo.
To the centimeter.